So data that involves counting, and continuous is data that involves fractions or decimals. So I'm going to draw like a smooth line on that, because it's too much. Okay, and so Chloe was exactly right. So let's just come up with some examples of things that involve counting. So apples you buy at the store. I'm going to write the number of apples you buy at the store. Or sometimes you're counting people. And you're counting people. If you were counting how many bills you had, okay, or how many coins you had, yes. If I was counting how much money you have, can't you have half of, like a half of $1? You could have $1.50, right? And so on. So it kind of depends on what exactly you mean by money. Data that involves fractions or decimals. Okay, weighing something. So actually, I just went to Meijer last night. Some of the things I bought in the produce section were based on how many I bought. Like green peppers, they were 3 for $5. So I had to tell how many green peppers I bought. But some of the things I bought were based on how much they weighed. Like bananas, I think were 54 cents a pound. So I had to put them on the scale, and then I had to do 54 times, let's say I got 1.3 pounds of, that's how much I paid for bananas. Okay. So which one was discrete? Which one was, I had green peppers and bananas. Which one would involve discrete and which one would be continuous if I was graphing it? Caitlin?
Would the green peppers be discrete?
They would, because I would graph 1 at $1.67, then 2 would be the next price up, and then 3 because they were priced per green pepper. That would not be connected. But bananas, it didn't matter. I was doing them on their weight, and I even typed in 1.3 pounds, right? That can have a decimal in it. So when we dot some graphs, we need to connect them between there to show, hey, there's values in between there. I didn't find what they were. Okay. So weighing something, or how about this? Measuring something, or temperatures outside. Those would involve fractions and decimals. Okay. And so what we're going to do next is we're going to talk about 2 different things. One of them we're going to connect, and one we're not going to connect. And we'll talk about why and why not. So let's first look at this one. So today when we're graphing things, let's remember that we can put things in for X, and then we can figure out what their Y values are, and then we're going to plot them. So I'm going to pick some values for you, and I have this yucky fraction here because I did that on purpose. Make sure that we don't forget how to do those. So I have to multiply by 1/3. So I'm going to pick some numbers that I know multiply nicely into 1/3. Okay. So I'm going to put -6, -3, 0, 3, and 6. When you're picking values, you do not have to pick those. You can go ahead and use your calculator. If you don't have a calculator, you can use one of mine in the drawer. These are the X values, let's plot the Y values. So in here I'm just going to show my work. I'm going to do 1/3 times -6 plus 2. What's 1/3 times -6? 6/3, which is 2, -2. -2 plus 2 is going to give me a 0. If you're not understanding the mental math there, then you probably should have a calculator out. All right. Then, now, do you see I'm putting these values in for X? Okay, I'm hoping you know how to do that. That's something we've done before. Negative 1/3, or 1/3 times negative 3 plus 2. What,
Negative 3 over 3.
which is negative 1, right? Negative 1 plus 2 is?
1.
Good. Let's plug in 0. 1/3 times 0 plus 2 is 2. 1/3 times positive 3 plus 2. This is 3 over 3, which is 1. 1 plus 2 is 3. Then finally, 1/3 times 6 plus 2. 6 over 3 is 2. 2 plus 2 is 4. Okay, so guys, when I'm plotting these now, this is the x value, this is the y value, just to review. Negative 6, 0 should be right here. Negative 3, 1. 0, 2. 3, 3. And 6, 4. Okay. Now, when you are just given an equation and you're not given any words, we are always going to connect that. When you're just given an equation and you're not given any words, because couldn't I have picked whatever I wanted in those problems? I could have picked 1.5 if I wanted to. So what I would like you to do is just take a straight edge, and by that it can be the side of a calculator, the side of a piece of paper, and make a nice straight line. When we see things like this, let's review from last year. Do you guys remember y equals mx plus b, hearing about it? Yeah, these look like lines. And you're right, we're not going to talk about slope just yet, but 1/3 is the slope, right? Rise over run? Okay. So hopefully it isn't a surprise that it looks like a line. Okay, so now here's going to be one that's linear. Linear means it looks like it goes in a line, but we're not going to connect it, and here's why. At the local video store, you can rent a video game for $3. It costs $5 a month to operate your video game player. Let's say there's just other costs, like think electricity and that kind of thing. The total monthly cost, C of V, depends on the number of video games you rent. Use the function rule C of V equals 5 plus 3V. And that just means the cost of V video games is 5 plus 3V. So first of all, I'm not going to pick a ton. I'll pick like a few values, not all of them. I'm going to pick 0. Why did I not pick a negative one? That would be negative video games. Okay. What would be the next possible input? 1, 2, 3, 4. Okay, let's at least do 0, 1, 2, 3, and then you can see the pattern, I'm hoping. And so, right here I'm going to write 5 plus 3 times 0. What is that? Well, 3 times 0 is 0. What's 5 plus 0? 5. 5 plus 3 times 1. 5 plus 3 times 2. 11. And 5 plus 3 times 3. 14. Good. Okay. Are you guys seeing the pattern, by the way? What are these going up by each time? 3. Okay, so you could continue the pattern if you wanted to. The next one will be 17. So let's plot this now. 0, 5. And I'm going to label these in a second. Let's label them right down. V was the number of video games. That goes on the bottom. We always want to label our axes. And here, this was the cost. I'm going to put the cost on the y-axis. And always that's going to be the case, guys. You always want to put the independent, what's in the left side, on the x-axis. And you always want to put the y, or the dependent, on the y-axis. Alright, so then 1, 8. 2, 11. 3/14, and I could continue the pattern. I could keep going till I went off the page if I wanted to, okay? All right, I am not going to take my ruler out, and I'm not going to connect those. So this data is discrete. Because you can't rent half of a game, or a quarter of a game, or a fraction of a game. You can't rent half of a game. This doesn't work that way. Okay. Let's graph. Let's practice some more graphing, guys. So, at a ball game, they charge $2 for a hot dog. The function c of h equals 2h describes the cost of each hot dog. Use the points for each input value. Okay, let's graph. Should we start at 0 again? 0, 1, 2, 3, 4. Now notice, in this one again, I picked positive. Why? Because I'm not going to have negative hot dogs, okay? So notice the difference here. Again, down here, you're going to notice I'm going to pick negatives and positives. Because if I want a good graph, I want to have different kinds of numbers. But we don't pick ones that don't make sense. Okay, this is an easy one. 2 times h. Do I even need the middle column? Can we do it without?
Yeah.
0. What's 2 times 1?
2.
2 times 2. 4. All right. What label should we put on the x-axis? What are number of hot dogs? And here we're going to put the cost. Okay, let's plot them. 0, 0, 1, 2, 2, 4, 3, 6. And you know what, guys? This is a real easy one where I can graph till I go off the page even though I didn't plot them, right? And the pattern would continue. By the way, just because the pattern continues, do you notice that continuous is not the same as continuous? Because they're too continuous, it has to do with in between the points. It's continuous through the point. Continues would mean beyond. On the last assessment, I asked a question about that, and some people said something, it's continuous because it goes on forever. This is not continuous, is it? But it does go on forever. It's not continuous because you can't have half of a hot dog. You're not going to buy half of a hot dog. All right, so this is discrete. You can't buy fractions of hot dogs. Okay. Now, these two, do you see how I'm not giving you a word problem? My advice to you is when you're picking values to put in for your table, is when I don't give you a word problem, you want to pick up some positives, some negatives, and 0, and I would go in order. Like, in other words, I would put 0 in the middle, and let's see, 1, 2, -1, -2, and then it's going to kind of go in order when you're doing that. Okay. All right, who knows what this symbol means? Oh, good. What is that called? Absolute value. Absolute value, you learned in pre-algebra, is the distance from 0. And so we don't have negative distances, so when you input something, you evaluate. It's like a grouping symbol, but then at the final thing you do to remove it is you make it positive. So I'm going to write what I'm doing. If I was putting this in, I'd do the absolute value of -2 plus 2. The absolute value of -2 is, you're right, 2. So this is 2 plus 2, or 4. Okay, absolute value of negative 1 plus 2. This is actually going to become 1 plus 2, which you're right is 3. The absolute value of 0 plus 2. So the absolute value of 0 is just 0. We can't change the sign of it. Okay, now, this is where sometimes people go crazy. They'll be like, oh yeah, that's negative 1, you changed the sign. No, no, no. How far is 1 from 0? It's 1, okay? So if the values are already positive, you keep them positive. This is 1 plus 2, which is 3. And then the absolute value of 2 plus 2 is 4. Now, here's the deal about an absolute value graph. And I say absolute value starts with a V, and absolute values always look like a V. Okay, so watch what happens. Negative 2, 4, negative 1, 3, 0, 2, 1, 3, 2, 4. Now, I could have picked numbers in between because it was an equation. So I am going to draw lines through that. Okay. Okay, good. This last one's kind of a toughie. So first of all, I'm going to do the same thing. I'm going to put 0 in the middle, and I'm going to pick numbers above and below 0. So I'm going to do 1, 2 above, negative 1, negative 2 below. Okay. Now, here's what you have to remember about the absolute value. It is a grouping symbol. Treat it like a parenthesis. So in the order of operations, you have to do it first. Okay? So you're not going to do negative 2 times that first. You're going to do the absolute value first. I'll write that down. Do absolute value first. Okay, so here we go. So be very careful here. I'm not going to do negative 2 times negative 2. Do the absolute value first. What's the absolute value of negative 2? Positive 2. Agreed? So I am going to actually do negative 2 times positive 2 plus 4. What is that going to give me? Careful.
4.
Negative 2 times positive 2 plus 4. 0. Because negative 2 times 2 is negative 4. Negative 4 plus 4 is 0. Okay. Let's put it in. Be very careful of order of operations. We're going to do grouping symbols first. Well, so first we're going to take the absolute value of negative 1. What is it?
1.
Positive 1. So we're going to do negative 2 times positive 1 plus 4. What is that?
2.
That's 2. Wait, the next one's 2.
Oh, that's 4.
Hold on. Now 0 I don't need to change the sign on, right? So negative 2 times 0 is 0. 0 plus 4 is 4. So now you're right. These ones, Chloe, go back to, yeah, because negative 2 times, when I did the absolute value of negative 1, it became positive 1, and the absolute value of positive 1 is also 1. So negative 2 times positive 1 plus 4, which gives me a 2. And negative 2 times the absolute value of 2 plus 4 gives me a 0. Now this still should look like a V though. Let's plot our point. Oops. Negative 2, 0. Negative 1, 2, 0. there. So yes, this C is pointing downwards, and here's why actually. Because of that negative number in front. What it did is it flipped everything the opposite way. Okay, and so these two would be considered continuous functions. They're always continuous when you're just given an equation. Okay, hopefully that was good.